Hello there, this is Rafin again. So this week we're gonna do experiments, hands-on experiments. I know in online it's very hard to do hands-on experiments, but I will actually show you how to do it. So then uh, you will see. So in module 1 is done. We're in module 2, which is single phase transformer. So we'll start with lecture 3. I will upload everything today. So in lecture 3, we'll see the experiment 1 PDF. So the name of this lecture is Construction of Single Phase Transformer. So there are some videos that I've uploaded: transformer code type, transformer winding type, transformer, three-phase transformers, general construction. I'd like you to actually see them. Since this is not a theory class, this is a lab class, so I'm not gonna actually explain everything. So I hope in your theory class you get enough information about this. So today we are gonna do experiment number 1, which is related to construction of a single phase transformer and transformer voltage, current, and impedance ratio. So if you click here, you can click this link, or you can click this link. So either way you'll be able to download it. I hope there won't be any problem like before, like the last class. So this is the PDF of it. So purpose of this experiment, so this is the name of this experiment, and the purpose of this experiment is to study the relationship between voltage and current in a transformer. If we look at the circuit diagram of a transformer, so this is our setup. So there are couple of windings in the primary side, couple of windings in the secondary side. I'll show you in short, like in another video, the experiment. So where you will see different segments of a winding. So basically, this from H1 to H5 is a winding. Sorry, H1 to H5 is the primary side. So there are a couple of division like between them, like H1 to H3 is like there are some turns, and this is a winding, and we have another winding from H4 to H5. And I know from theory class, I guess you have learned this, the the number of turn is crucial for a transformer. So if we have like say for example on the primary side we have 20 turns, and secondary side we have 10 turns, then that means this transformer is a step down transformer, because the turns of the secondary is lower than that of uh, the primary one. So if we want to actually increase the amount of turns, then we can actually add them up. So in this case we actually connected H3 and H4 so that we have a larger number of turns. So we'll supply some AC voltage to the primary side, and we'll measure uh, the current and voltage and power factor. We are not going to use any ammeter voltmeter, rather we use a power analyzer. You will see the later video, second video. And on the secondary side, if we supply, say for example, 140 volts, we'll get some voltage on the primary secondary side as well. And what will be the amount of voltage? It will depend. It depends on the turns ratio. So I'd like you to actually calculate all of this. I will conduct the experiment. I'll show you the different readings. I'd like you to actually make a table. I'll provide the table, and I'd like you to actually put those values and calculate the values, and make an um, make an observation. So on the secondary side, if we don't have any load, you will see there will be some voltage. But in this experiment, we're going to use a resistive load, although we're supposed to use an inductive load as well. But for the time being, this experiment, we're going to, since this is the very beginning, so we're going to use resistive load. So we'll supply a certain amount of voltage with the help of power analyzer. We'll measure the input voltage, input current, input power, input wattage. And from the output side also, we're going to use another power analyzer, measure the voltage, current, power, and um, the power factor, so on and so forth. So in this experiment, it is as simple as that. And in report, what you're gonna write, you're gonna write the purpose, uh, this sentence, that's it. And in theory, this is the theory part. I'd like you to write 1 or 2 sentences, not more than that. You don't need to actually write the whole thing. I'd like you to actually write whatever you know about a transformer. Then I'd like you to actually include these, um, what is it called? The equations and different terminologies, like for instance, what is IS, what is NP. I'd like you to actually include all of them. And this is the transformation ratio. So in the table, when you actually collected collected all the uh, voltage value and current value, I'd like you to actually calculate a transformation ratio with regard to voltage values. Like for instance, if the supply voltage is 140 and the secondary voltage is 70 voltage, in that case, the ratio will be 2. And I'd like you also to actually calculate the transformation ratio uh, with these current value, like the primary current and secondary current. So I'd like you to compare them. You will see that it is not accurate enough, like an ideal case, because there are some losses. In transformer, there are so many losses. The core of a transformer will have some loss. The primary winding will actually have some loss. Secondary winding will have some loss. So in the report, I'd like you to actually make a table, and whatever um, the measured value, you will write it down, and you will calculate the transformation ratio, you will calculate the impedance value. So there will be impedance value on the primary side and the secondary side. I'd like you to calculate them as well. And I'd like you to calculate the uh, transformation ratio with regard to this, uh, what is it called, impedance also, like primary side's impedance and secondary side's impedance as well. So the impedance, I know, I hope that you already know all of this. I'm not gonna explain everything. So if you put the value of here, like impedances value and voltage current of primary and secondary value, and take a ratio of it, it will look like this. So ZS will become ZP over A square. So I'd like you to actually include them in the report as a theory part, and then apparatus, whatever. So we will be using these equipments in this experiment, although we are not going to use ammeters and voltmeters, rather we'll use power analyzer. So we'll use 2 power analyzers. So, and the uh, procedure is very simple. I have explained again, like the starting of this video, when I say that we connect everything like this figure, then we will supply some certain voltage, and we will take the reading of the supply voltage, supply current, and secondary sides, load side voltage, load side current, and we'll uh, write it down and make a table and do some calculation. We are not going to do this. So in the report, I don't want you to actually include this figure 2. And these are the questions that is related to this one. I will actually provide some additional questions. You don't have to answer these, but I will actually give you some questions that you need to answer. And in your report, you'll have to include diagrams of each circuit. So there is only one circuit, so you will draw that one. You'll calculate everything and make a table. Um, the table will have supply voltage, supply current, so two, and power of the primary side, power factors of the primary side. You will need to calculate the impedance of the primary side. Then you need to measure. So I will be measuring that. All you have to do is you'll have to take a note of those values. For instance, primary side's current, voltage, power, power factor, secondary side's power, voltage, uh, current, and power factor. You need to calculate primary side's impedance, secondary side's impedance, and turns ratio. So turns ratio or transformation ratio, which is you will compare the primary side's voltage and secondary side voltage like this. You will use this formula. So in one case, you will use this portion, and in one case, you will use this portion, and in another case, you will use ZP, yeah, ZP and ZS, that impedance of the primary, impedance of the secondary side. So, and you will observe there are some uh, dissimilarities between the values. It's supposed to be equal, but it is not, because I told you that there are some losses in the core, in the windings, and even the load side. So you'll have to make that table, and you'll have to do all the calculations. And there are errors. I told you that there will be some errors because of the losses. So you need to actually take those into the consideration and explain why those errors happen, and answer some questions that I'm gonna ask you to answer. So that's all for today. If you have any question, you can email me at any time. That's it. Thank you. Have a good one.